Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
In this lecture, we are discussing Haskell versus Solidity for smart contract development. Let's talk about Haskell and the pros of this programming language. Haskell was invented in the late 80s and has more capabilities than Solidity. Haskell is especially used for financial instruments and financial smart contracts. Haskell is a functional programming language. So if you're a coder in something like Java, Python, then you'll find that Haskell looks very different. Haskell is a functional programming language where everything is a function, and it can be harder to read Haskell and have a larger learning curve for beginners, but you get the benefits of functional programming languages. As well, there is type inference from the Haskell compiler, which leaves less room for error using Haskell compared to something like Solidity. As well, Haskell is fast and has built-in functionality to be fast. But let's talk about the pains. Haskell uses lazy evaluation, which can lead to performance bottlenecks and means that it's hard to easily reason the execution order of your code. As well, the library quality and coverage is inconsistent. The tooling can be limited and slow, and compilation can be slow, whereas runtime is fast. Package management can be a pain, but there are tools like Nix that help with managing Haskell packages. Haskell is a functional programming language which is different from an imperative programming language like Python. Using a functional programming language is used and especially beneficial for smart contracts that handle a lot of money or identities or data where there is high risk and you really don't want to have any problems. There is a small margin of error. If you're building something like a website, it makes sense to use an imperative programming language like JavaScript, but for handling sensitive data or millions of dollars of cryptocurrencies, a functional programming language helps to reduce the risk. Because with Haskell, the margin of error is smaller compared to an imperative programming language, which is why Haskell is used by top-tier banks for controlling air traffic and for processing X-rays. So that's an overview of Haskell, a functional programming language, compared to Solidity, an imperative programming language. In this lecture, we are discussing what is Cabal used for Haskell development, Haskell smart contracts, and managing projects for the Cardano blockchain. Cabal is the standard package system for Haskell software. You can use Cabal to configure, build, install, and distribute Haskell projects. So you can manage and build your whole Haskell project with all of your modules, all of your files, all of your smart contracts. There's also the Cabal command line tool for working with Cabal packages. You can install existing packages, make your own packages, work with local packages, or install packages from online, or automatically install dependencies that are required. So that's an overview of Cabal. And next up, we're going to discuss what is Hackage, commonly used with Cabal and Haskell. In this lecture, we are discussing what is Hackage, commonly used for Haskell and Cabal development. Well, the Cabal command line tool allows you to install packages from remote Cabal package archives. So you can install dependencies from online, so that way you don't have to reinvent the wheel from scratch. You can instead use packages that other developers have made and that they have published. By default, Cabal is configured to use Hackage as the package archive. Hackage is a website with an archive of Cabal packages. It's Haskell's central package archives. So if you want to find Haskell projects, modules, or libraries, then you can look for them on Hackage. There are thousands of libraries and applications in the Cabal package format. So this way you can use Hackage to access those packages and use them in your Cabal project. The official website for Hackage is hackage.haskell.org. So that's an overview of Hackage, commonly used to install packages, which likely you'll have to do in every project. Coming up next, we're going to discuss what is a Cabal package. In this lecture, we are discussing what is a Cabal package for Haskell development. A Cabal package is a unit of distribution of a package. It has a name and a version number used to identify the package, like file path -1.0. A Cabal package can depend on other Cabal packages, and you can take advantage of Cabal's automated package management, which means if you install one package, you can install all the other packages required as well. A Cabal package is practical to help make modular programs. You can use a lot of packages that reuse code so you don't have to write all the code yourself. A Cabal package is not part of the Haskell language. It's a feature provided by a combination of Cabal and the Glasgow Haskell compiler, which you can read more about at haskell.org/GHC. So what does a Cabal package contain? Well, it contains, first of all, Haskell software, which means libraries, executables, and tests written in Haskell. As well, a Cabal package contains the Cabal file, which is the extension .cabal. And we'll actually see this in our project. We'll have a .cabal file that contains metadata about the package in a human and machine readable format. You'll see the information about the package supplied by you, and as well the other packages that the package depends on. As well, a Cabal package contains a standard interface to build the package, a setup.haskell file. To read more, go to the official Cabal documentation. So that is an overview of the Cabal package. So coming up next, we are going to do a prerequisite section on using the command line. So if you've never used the command line before, then watch that prerequisite section. Otherwise, jump straight to the next section, where we're going to install Cabal, and then we can build a Hello World project with Cabal and Haskell. In this lecture, we are going to learn how to install Cabal along with Haskell and the Haskell compiler on Mac or Linux. So join me in your terminal or command line application. We're going to enter the following command, and you can also copy and paste this command because we'll include the source files for this section. So just go to the end of the section and download the source files, and then you can copy the command from the source files. Make sure you are not running the command line as a root or administrator user, just as a regular user. We're using curl to install from ghcup.haskell.org the ghcup package. So hit enter and you'll get this prompt: welcome to Haskell. The script will download and install the following binaries: ghcup, the Haskell tool change installer; ghc, the Glasgow Haskell compiler; Cabal, the Cabal build tool for managing Haskell software; Stack, an optional cross-platform program for developing Haskell projects; and HLS, a language server for developers to integrate with their editor, optional. ghcup installs only into the following directory. Currently, I have it in my root directory because I am in my root folder in the terminal. And you can delete ghcup at any time. Press enter to proceed or Control-C to abort. This script can be rerun at any given time. I hit enter and I get the message detected ZSH shell on your system. That's because I'm using the Z shell as my default shell in my terminal. You might have a bash shell if you have an older version. You'll get the message, do you want to add ghcup automatically to the required path variable? You want to select yes. You want to add ghcup to a path variable list. That way you can reference ghcup as a variable name. So we're going to hit P or A for prepend or append. You can just hit enter as well for the default P. Next, we get the message, do you want to install Haskell Language Server? HLS is a language server that provides integrated development environment-like functionality and can integrate with different editors. We don't need it, so we can hit N for no. Do you want to install Stack, a Haskell build tool similar to Cabal? Don't need that, so we can hit N for no. And remember, you can rerun the script at any time. Then we get a downloading message, the time spent, and if we need an upgrade or update. We get a system note on OS X. In the course of running GHCup, you'll be given a dialog box to install the command line tools. Accept and the requirements will be installed for you. You'll then need to run the command again. On Darwin M1, so the newer Mac computers with the M1 chip instead of the Intel chip, you might also need a working LLVM installed via brew. So you can use brew install LLVM if needed and have the toolchain exposed in path. So which means you have to add LLVM to your environment path if you're on an M1 Mac. Next, you'll be asked to press enter to proceed or control C to abort, hit enter, and the installation will occur. First, we'll download the latest package list from hackage.haskell.org. You'll get a message, okay, your Z shell has been modified with the environment variables. Restart your terminal for the changes to take effect or type in a command to apply the changes to the current terminal session. Then you'll get the message all done. To start a simple REPL, run GHCI. To start a new Haskell project, run Cabal init. To install other GHC versions, run GHCup TUI. If you're new to Haskell, go to the official Haskell website to read more. So in order to use our new variables, our new packages, we have to either restart the terminal or enter the command. Now we can access tools like Cabal. In this case, we can check Cabal version. So in this case, we're using Cabal install version 3.6.2.0. And that's the main focus of this installation. But we also have access to other tools as well. Remember, if you go back to the very top, you'll see that. For the installation, we also got GHCup, GHC, Cabal as well. So we got those three. So that is how you can install Cabal on Mac or Linux. In this lecture, we are going to learn how to install Chocolatey on Windows. Chocolatey, commonly called Choco as well, is a free open source package manager for Windows. It allows you to install packages quickly, such as Cabal. Join me in your command prompt application. So search for the command prompt application, but make sure you run it as the administrator. So you can right click on it and run as administrator. You'll get the message, do you want to allow this app to make changes to your device? Yes. Then we can open that command prompt. Next, we are going to paste in the following command, which you can also find in the source files for this section. So you can just go to the end of the section and download the source files where we've pasted in the command to use. This command is going to access the PowerShell, and it's going to download from chocolatey.org an installation of Chocolatey into your user's root folder, so the C folder typically, /chocolatey/bin. So again, if you want to copy and paste the command, just go to the source files for this section. I'll show you what it will look like. Here we have included files of details showing how to install Chocolatey on Windows. So this is the command that you will enter. So it may look complex, but it's just using the Windows PowerShell to install Chocolatey into chocolatey/bin. So then, once you've entered that command and hit enter in your command prompt, you'll get some messages like installing Chocolatey on local machine, creating Chocolatey install as an environment variable. It's very likely you'll need to close and reopen the command prompt before you can use Choco. Restricting write permissions to administrators, setting up the Chocolatey package repository, creating Chocolatey folders, and then getting a message that Chocolatey, choco.exe is now ready. You can call Choco from anywhere, command line or PowerShell by typing Choco. You can type Choco / for a list of functions. If you don't see the prompt Chocolatey version, then this means you likely had a problem with installing Chocolatey. You can try restarting the terminal or restarting your computer. Make sure Chocolatey was added to your environment variables, or just try the installation again. You may already have it installed on your computer as well. So that is how you can install Chocolatey, a popular package manager for installing packages on Windows such as Cabal. In this lecture, we are going to learn how to install the Haskell compiler and Cabal on Windows. So join me in your command prompt application in administrator mode. So you can search for your command prompt and run it as an administrator. You can right click on it and select run as administrator. You'll get the message, do you want to allow this app to make changes to your device? You select yes, and then the app will open up. Here we are going to use the command prompt to install Haskell compiler and Cabal. And we have to run in administrator mode so that way we can install these packages with Chocolatey. So this assumes you have Chocolatey installed on your computer. Chocolatey is a popular package manager for Windows. You can access it with Choco if you have it installed. And in order to use Chocolatey, you'll have to be in a PowerShell or in the command prompt as an administrator. Then you can use the install keyword to install GHC and Cabal. These are two packages, the Glasgow Haskell compiler to read Haskell and the Cabal package as well. So we can hit enter, and Chocolatey is going to install the following packages. By installing, you accept licenses for the packages, and this package wants to run Chocolatey install.ps1. If you don't run this script, the installation will fail. You can automatically do this next time by adding the -y flag to your command. Do you want to run the script? We are going to select Y for yes. You can also select A for all. This is going to download Cabal 64-bit because I have a 64-bit version of Windows. Likely you'll see 64-bit as well because that's the most common newer type of Windows computers. You can also check what version of bit you have, 32 or 64, just by searching up bit in your search bar on your computer. And make sure that the bit version matches up with your computer, which it likely will. So here we're downloading Cabal, and the environment variables have changed. That is a good sign because it means we can access Cabal and GHC as a variable in our command prompt. But to access those new variables, we have to reopen the command prompt or run the command refresh env to refresh the changes and get those new variables. So we can scroll down and we get another message. The GHC package needs to run a script. So we hit Y for yes. Again, you could just hit A for all. This is going to download GHC, the Glasgow Haskell compiler, which will allow us to write Haskell scripts and then compile them or read them. So that way they can be read and used. So that is going to download GHC. Commonly, if you're using Cabal, you need GHC as well. So that's why we install both at once. So let's allow for the extraction of the GHC installer to work. Remember, Chocolatey is doing all the work for us here as our package manager for Windows. Chocolatey installed for us Cabal, and now it is going through GHC, the Glasgow Haskell compiler. And we get the message that we have downloaded the package and the path environment variable will be changed. That is great. We want to be able to access GHC via our variables. So now we can check if we have our variables. So first we can call refresh env or just restart the terminal. This will refresh your environment variables. So then you can use GHC. You can check if you have it. All right, so we have GHC 9.2.2. You can check your version directly as well with a flag. Okay, so we have the glorious Glasgow Haskell compilation system, version 9.2.2. We can also check Cabal. Can we access it? For Cabal, you actually have to directly access a command or a flag like the version. So don't be afraid if you see no command given. This just means you can access Cabal, but you didn't give it a command. So it just means Cabal exists, but you didn't give it a command. So if you can give it a command or a flag like version, and we see the version that we have. So if you see these messages, it means you have installed the Haskell compiler and Cabal. If you see an error message, try restarting your terminal, restarting your computer. Try making sure that the packages were added to your environment variables, or try the installation again. This is not the only way to install the Glasgow Haskell compiler and Cabal. You can also get it via the Cardano CLI and other methods, but Chocolatey is a very popular method for installation.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.